Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abudiwa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have our National Senior Certificate, grade 12. And then this is Mathematics, Paper 1, November 2024. Paper that was just written last year around this time. So we're just going to be using it to practice for our upcoming November 2025 Mathematics Paper 1, which will be written around the first week of November. So we have our max, it's 150, and then the time is 3 hours. So hopefully we'll be able to finish off this paper within less than 3 hours. So just going through the question paper and showing you how to actually go about it. Okay, so let's start. We have our question 1, which is our algebra, as we know. And then obviously, when it comes to this question, you should be aiming for at least 90%, right? 90% of whatever that you've been given there. So if ever you're going to get anything wrong here, can be 1.3. But then out of this 27, you are hoping to get something like 24 because all these questions, I believe you've been doing them repeatedly and now you can see that they never change, right? So we have our 1.1.1 here, which is this. So it's the most basic solve for x already in standard form. So we know if we have a question like that, all we have to do is just say x is equals to 0 or x is equals to 3. And then they're just going to mark 1 for this and 1 for that. So that's your 2 marks there. Now for 1.1.2, we have 2x squared plus 1 is equals to 4x. And then we have a statement that says correct to 2 decimal places. Now you always have to understand that whenever you have that statement, it simply means that you have to apply your quadratic formula. But before you can apply quadratic formula to this one, you need to first rearrange it into standard form, right? So it needs to be in the form of ax squared plus bx plus c, so that you can be able to visibly see your value of a, b, and c, right? So what we are going to do is first write it in standard form. So by taking the 4x and then we have negative 4x and then plus 1 equal to 0. So this is now in standard form, meaning our a value is the coefficient of x squared, and then our b value is the coefficient of x, and then our c value is the constant 1, right? Then now we can write out the formula for the quadratic formula. If you ever forget these formulas, guys, do not be ashamed to go to your data sheet. The last page of the question paper is your data sheet where you have all these formulas, right? So you can just check them there instead of having to write the incorrect formula. So negative 4 squared minus 4, our a is 2 and then our c is 1, all over 2 multiplied by 2. Then obviously at this point, you're just going to grab your calculator, aka umshini ibalo, and just punch all of this. So you have your x is equals to 1.71, or your x will be equals to 0.29. Now, obviously, you know you have to first start by a positive here and then followed by negative. So at the end of the day, you must have 2 different answers, right? So, okay, that's it. So just like that, you have bagged yourself 4 marks, right? Now, if you are curious about where you will actually get the marks, there is a mark for the standard form. There is the mark for the correct substitution here into the quadratic formula, and there is a mark for each of the answers, right? So that's your 4 marks there. Now, obviously here you had 1 and 1. Okay, so that's it. So 1.1.3, we have x squared minus 2x minus 3 is greater than 0. So what are we supposed to do there? Already we can see that this is in standard form. Now you will remember that I did mention that when you see your inequality sign from the question is facing that side, then you always have to remember that your answers normally end up like this, right? This is where you will have your x is less than the minimum value, or your x is greater than the maximum value. So that's if your inequality sign is like this from the standard form. Now from the standard form equation, if your inequality sign is facing the right-hand side like that, it's a greater than sign, then you normally have your solutions like this. But then if it's facing that other direction from your standard form equation, then normally what I did say is that your solutions will be the one whereby you have a combination here where you say x is greater than the minimum value, but x will be less than the maximum value, right? So this is normally where you have something like this, where the answers will be outside of the critical values. And then this is where you have your solutions being inside of the critical values, right? So always note that. So you just look at your sign from the standard equation. So you have to look at it when you have already made sure that it's in standard form, right? Okay, so what are we going to do in order to answer that? So for 1.1.3, we are going to say this is x squared minus 2x minus 3 greater than 0. So we can all agree that it's easier to factorize this because the only factors of 3 are 1 and 3. So we'll have x minus 3 and then x plus 1 greater than 0, right? Now, obviously here, your critical values now will be what? X will be equals to 3, or your x will be equals to what? To negative 1. But then obviously, because we are dealing with inequalities, you should not leave your answers to the critical values. This is the point now where you should write it in correct format. So in correct format, you have to say your x is less than the minimum value, which is negative 1, or x is greater than the maximum value, which is 3. And then that's how you have your solution. Or you can represent it in that fashion to say this is your negative 1 and this is your 3, and then you just shade off these parts here to show that your equation or your inequality will only satisfy for values that are outside of the critical values. Then, okay, just like that, you beg yourself 4 marks. Where are we going to get the marks? We're going to get the marks for the factors. So the factors will give us a mark, and then the critical values will give us a mark, and then also the answers will give us a mark, each of the answers. Okay, so now we move to 1.1.4. So this is your exponential laws. So we have your 2 to the exponent of 2x, so 1.1.4. And then minus 2 to the exponent of x plus 2, and then minus 32 is equals to 0. Now we can choose to shire it clean, or we can use the K method. Let's start with the first option where you just tackle it clean like that. So this is 2 to the exponent of 2x, and then this one will break down to 2 to the exponent of x, and then 2 to the exponent of 2, right? And then minus 32 is equals to 0. Now 2 to the exponent of 2, we know that this will have to give us what? 4. So I'll just write 4 here in front, and then 2 to the exponent of x. So I didn't change anything, only the format. I just started with the coefficient here, then followed by that. Now at this point, I can just factorize this. Remember, I know that 2 to the exponent of 2x is the same as having 2 to the exponent of x and another 2 to the exponent of x. So I can just factorize this by saying each bracket will have 2 to the exponent of x. Now, I want the factors of 32. These factors of 32, when you multiply them, they must give you 32. But then when you subtract them, they must give you 4. What are those factors? We can say the factors are 8 and 4, right? 8 multiplied by 4 will give us 32. But then 8 minus 4 will give us 4. So perfect. Now, it's just a matter of looking at your signs here, and then you will determine that the bigger value here would have to have a negative sign, and then the other value would have to have a positive sign. So this is 2 to the exponent of x, and then plus 4 is equals to 0. So negative 8 multiplied by 4, that's negative 32. Negative 8 plus 4, that's negative 4, right? So look at this, right? Okay. So now at this point, we can see that this is already in standard form. So we can equate each and every bracket to what? To 0. So this is 2 to the exponent of x minus 8 is equals to 0, or 2 to the exponent of x plus 4 equal to 0. Now this is 2 to the exponent of x is equals to 8, or 2 to the exponent of x is equals to negative 4. But then this one, immediately we're just going to say it's not applicable because there is no exponent value that you can put here that will result in a negative value, right? So there is no such thing as a negative value from an exponent. So this is not applicable. But then the 8 here, we can write it in what? In exponential form. So 8 can be written as 2 to the exponent of 3. Why are we doing that? It's because we want to take advantage of the law that says in an equation, when the bases are the same, we can just drop off the bases and equate the exponents. So the bases are 2 and 2. We drop them off and then we just equate the what? The exponents. So that is x is equals to 3. So we only have one solution there. Our x is equals to 3. There is no solution for this one because it's negative, and then there is no exponent that produces a negative value. Now, this is one way in which you could have done that for 5 marks, right? Okay, now suppose that you do not understand this part whereby we were able to break down the 2 to the exponent of 2x to that and that. You can still use the k method, whereby now you're saying, okay, this kind of looks complicated to me. Let's say this is 2 to the exponent of 2x minus 2 to the exponent of x, and then 2 to the exponent of 2, and then minus 32 is equals to 0. Now, we do know that 2 to the exponent of 2x, according to our exponential laws, is 2 to the exponent of x and 2 to the exponent of x. So in this case, we're going to say let 2 to the exponent of x be expressed as k. So instead of solving for x here, I'll start by solving for k. Now, if I'm saying that 2 to the exponent of 2x is 2 to the exponent of x multiplied by 2 to the exponent of x, what I'm simply saying is that this is k multiplied by k, which means all of this will be what? K squared. And then 2 to the exponent of 4 to the exponent of 2 is 4. Remember, the 2 to the exponent of x can be replaced as k, then minus 32. So I am still going to factorize this the way I did, minus 8, then k plus 4 is equals to 0. Now my k is either equal to 8 or my k is equal to negative 4. But now I have to remind myself that, remember, k was not what I was initially calculating. K was just only a scapegoat for now, right? What I'm trying to calculate is what? X. I'm trying to solve for x. So I have to say, but k is equals to 2 to the exponent of x. What does this mean? It means where there is k, now I have to replace back by that 2 to the exponent of x. And then this is equals to 8. Also, again here, 2 to the exponent of x, which is equals to negative 4. Now, at this point, we can see again that this will be not applicable. And then we still continue with that one. This is 2 to the exponent of 3. And then x is equals to 3. Bases are the same, so we equate the exponents. So either way, you still end up to the same answer there. So pick your poison, pick which one actually makes you to understand all this concept. Okay, sharp. Then 1.1.5, we have this. So 1.1.5, this is square root of negative 2x plus 4. And then this is outside, right? So we have minus x is equals to 2. So the first thing that we are going to do here, we know with this kind of questions, we should always isolate the root, right? So we don't want anything in front or after the root, right? We just want an equal sign. So the first thing that we are going to do is take this over to that side. So we want to have square root of negative 2x plus 4 is equals to x plus 2. So this negative x will become positive x. Now at this point, we can see that our challenge is that we have the square root here. So we can't solve anything with the square root, with the expression still inside the square root. So how do we get rid of the square root? We square both sides. Remember the rule of maths, what you do on the left-hand side, you also have to do on the right-hand side. But then the purpose of the square here will just be to get rid of the square root. And then we'll be left with the negative 2x plus 4. Now here, because there's no square root, it means that expression would have to expand twice, right? So we have negative 2x plus 4. And then this will give us x squared. X plus 2x will be 2x. And then this is 2x. So all in all, we'll have 4x. 2 multiplied by 2, that's 4. Right? And then let's do our maths now. If we take this all over to that side, we have x squared plus 4x plus 2x and then plus 4 minus 4. And then, okay, so there's the 0 there. Okay, then we're going to have 0 is equals to x squared, 4x plus 2x, that's 6x, 4 minus 4, that's 0, right? So let's rearrange it. We're going to have x squared plus 6x equal to 0. The common factor between the two terms is x. So factor out x, we're going to have x plus 6 here equal to 0. So again, it goes back to this, right? How did we solve this? We know that at this point, all we have to do is just say x is equals to 0 or x is equals to -6. And there we go. We have our two solutions. But it is always very important to note that with this kind of questions, you have to take your values and test them against the expression or the equation to see if they both satisfy the equation. It is much possible that only one of the values will satisfy the equation. Let's see. If I decide to put 0 here, I'm going to have -2 multiplied by 0 plus 4 and then minus 0, right? So obviously this will leave us with square root and then square root of 4 and then square root of 4 is 2. So the left-hand side is equals to the right-hand side in this case, because all we are trying to do is we are trying to find out if we're going to be replacing by x here, will we still be able to get that 2, right? So we can see with testing with 0 here, we do get that 2. But then let's see with testing by -6. So if I put -6 where there's x, so that's -2 and then -6 here plus 4 and then minus -6. Let's see. So 2 multiplied by -6, that's 12. 12 plus 14, that's 16. Right, square root of 16, and then this is negative, and negative will give me +6. Now, square root of 16 is going to give me what? 4, right? And then 4 plus 6, unfortunately, gives me 10, which is not equal to this. So the left-hand side is not equal to the right-hand side whenever we are using what? -6. So what must we do now? We must come here and cancel off that value there. So it's a mark to come there and cancel off a value, right? So, where are you going to get the mark? Isolating the root, number 1. So if you isolate the root, that's a mark. Squaring both sides, right? It's a mark. So squaring both sides, it's a mark. So that means we were supposed to show that step and then square afterwards. Okay, then we squared both sides and then standard form. Where do we have our standard form? Right here. And then they're going to give us a mark only if we have cancelled out that value. So for someone who just wrote x is equals to 6 and x is equals to -6 without having to cancel off this one, they won't get a mark. So it's only 3 marks. So, but then if they see that you cancelled off that x is equals to -6, then that's when you're going to get the 4th mark. Okay, so nice. So you are noting all those. You are noting all those things that you need to be careful of. Then 1.2 says solve for x and y simultaneously. Okay, so 1.2. Now we know the rule with simultaneous equation is that if you are given 2 equations like that, you always have to look for the simplest equation. The simplest equation will most definitely be the one that is linear in most of the cases. So we can see that this has a square there, a degree. So that means we won't be taking it as the simplest equation. But when we look at equation number 1, this is a linear equation, right? So we can take this one and say we're going to work with equation 1. But then working with equation 1, again, we have to choose which variable do we make the standard, the subject of the formula meant to say. Now, always choose to make the subject of the formula the variable that is the lowest coefficient. Understand that. Make the subject of the formula the variable that is the lowest coefficient. Now, if you can check, x has a coefficient of 2. Y only has a coefficient of 1, meaning that we wouldn't be complicating this if we make y the subject of the formula, because there will be no need to divide anything out or create a fraction. So we're going to be working from equation 1. So this is y is equals to 3 minus 2x, right? So I will say this is equation what? 3. Now, it doesn't matter if you say negative 2x plus 3, still the same thing. Now you have equation 3. Remember that equation 3 and equation 1, that's just the same thing. So that means you have to take this equation 3 and substitute it into what? The equation that you haven't used yet. So substitute equation 3 into equation 2. This is always the process for your simultaneous. It never changes. So what does it mean? Where I see y, I would have to replace by this expression. So I will have y squared here. This means I will have to have 3 minus 2x squared plus x. And then where there is y again, I have to put the 3 minus 2x and then equal to 2. Now, obviously, the square here means that I have to expand this. 3 minus 2x. Now, here I can just multiply inside by this x. I will have plus 3x minus 2x squared. Then let me just transpose the 2 over to the side. Minus 2 equal to 0. Now, dealing with this, 3 multiplied by 3, that's 9. 3 multiplied by that, that's negative 6. Also here, we'll have negative 6. And then here and there, I will have positive 4x squared. And then plus 3x minus 2x squared minus 2 equal to 0. Now, let's look for like terms. Like terms, 4x squared minus 2x squared. And then other ones, we have negative 6x, negative 6x, positive 3x. And then we also have constants, right? So our constant is 9 and negative 2. So let's deal with those. So obviously, following the order of degrees, we'll have 4x squared minus 2x squared, that's 2x squared. Negative 6 minus negative 6, that's negative 12, plus 3x, that's going to be negative 9x. Is it? Okay. Let's see. Okay, negative 12, and then plus that, okay. Then we have 9 minus what? Minus 2. So 9 minus 2 will give us what? 7. So I was still confirming that everything is correct. Yes, we are still moving in the right path. So, okay, at this point, you obviously need to factorize this. Now, it's not a train smash. If you can't factorize that, you can still put it in your quadratic formula. Remember, I've been teaching you the trick to make it seem as if you factorized while you use the quadratic formula. So from the answers that you'll get in your quadratic formula, you'll have x is equals to 7 over 2 or x is equals to 1. So you want to make it seem as if you factorized. This is what you're going to do. You're going to take the 2, cross multiply it here. It's going to be 2x, and you're going to take the 7 and transpose it over to this side as minus 7. So that means your factor here is 2x minus 7, right? Then what are you going to do with this one? You're just going to take the 1 and transpose it over. So that's x minus 1. So these are your two factors that you have there. So 2x minus 7 and then x minus 1. Now, who will tell that you used the quadratic formula? No one. So this is 7 over 2 or x is equals to 1. Those are the values. But then remember, this is simultaneous, right? Simultaneous means that we solve for x and y, right? So that means since we have our x values, now it's time for us to find our y values. But how do we find the y values? You have to go back to the standard form equation, which is equation number 3, right? And then now you're going to say, for when x is equals to 7 over 2, you're going to have y is equals to 3 minus 2, and then 7 over 2. So which will give us what? So this and this will obviously cancel. 3 minus 7 will give us what? Negative 4. Right? And then we have another one. For when x is equals to 1, then that means I will have y is equals to 3 minus 2 multiplied by 1. And then 2 minus 3 minus 2 is just equal to 1. So there you go. You have your solutions for x and y simultaneously. Right. And then where do we get our marks with this one? So creating that equation there, in my case, it's equation 3, right? And then a standard form, where we have all of this in standard form, it's a mark. So before that, the substitution, and then standard form, and then both the x values get 1 mark. So if both your x values are correct, 1 mark, and then both y values are correct, 1 mark. So 1, 2, 3, 4, 5 marks, right? So nice. We have that 5 marks in the bag, just like that. Okay, then coming to the main question, 1.3. Biskala gela. Yeah. Consider the product bracket 1 plus 1 over 2, bracket 1 plus 1 over 3, bracket 1 plus 1 over 4. Each factor in the product is of the form y, bracket 1 plus 1 over n, for n is greater or equal to 2. Determine all the values of n for which the product will be an integer value. We want where the product will be an integer value. Now, looking at this, we are being told that our n values must start from 2 going upward, right? So as we can see here, the n value being the value in here represents that it's starting at 2 and then it's increasing gradually like that to the next integer, like that. But then we want where the product, let's look at this. The product is a what? The product is a result of multiplication. This is a result of multiplication, right? So we want where when we multiply in the brackets, we will have an integer value. So, okay, what we can do with this is simply add this, right? So if we can say 1 plus 1 over 2, we get what? 3 over 2, because that's more like the 1. We're going to write it as 2 over 2. 2 plus 1 is 3, and then 3 over 2 like that. So just like that, we're going to have 3 over 2. So look at the pattern. And then here we're going to have what? 4 over 3 followed by 4 over 3. So if it was just a matter of multiplying this 2 here, then it was just simply this. So this is that, and this is that. Cancel that, and then this will give us 4 over 2 is equals to 2, which is an integer value, right? But then this happens when our n here is equals to what? This happens when our n value here is equals to 3. So this is 4, n is equals to 3. Now let's continue and go for the one where n is equals to 4. So that means we have to continue and say 3 over 2, 4 over 3. Note that I'm adding these ones for 4 over 3. And then when I add these ones, I'm going to get what? 5 over 4. Now, if I have to deal with this one, this will cancel, that will cancel, that will cancel, this will cancel. I will have what? 5 over 3. 5 over 2 meant to say, which is not an integer. Not an integer. So that means we won't be considering when n is equals to 4. Let's skip now and say we continue to when n is equals to 5. So 3 over 2, 4 over 3, 5 over 4, and then 4 over 5. So this is the 5 now. So what happens? This cancels, that cancels. This cancels, that cancels. This cancels, that cancels. Then we are left with what? 4 over 2 again, right? Which is going to give us what? Oh, not that. Where do I get the 4? 6 here, sorry. So this is 6. Yes. So cancel that. Sorry for that. So this is 6 over 2. And then the 6 over 2 here will give us what? 3, right? So, okay, let's continue with that pattern and see if it holds. Then if our n is now equal to 6, that means I'm going to have 3 over 2, 4 over 3, 5 over 4, and then 6 over 5, followed by what? We will have 7 over 6, right? So what happens here is that this cancels, that cancels, this cancels, that cancels, cancel, 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 cancel. Then we are left with 7 over 2, which 7 over 2 will not be an integer. So we won't be considering when n is equals to 6. Now let's consider when n will be equals to 7. So at this point, I think you actually pick the trend. So 4 over 3, and then 5 over 4, and then we have 6 over 5. We have 7 over 6, and then we have 8 over 7. So what happens? Cancel, 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 cancel. Then we are left with 8 over 2. 8 over 2 will give us what? 4. So basically what we are seeing here is that every time our n is an odd number, so when our n is 3, our n is 5, our n is 7, again, it will happen when our n is 9, our n is 11. So every time our n value is an odd number, that's when we have an integer value for the product, right? That's where we have an integer value when we multiply that product. So in this case, that means we are supposed to say what? Therefore, n must be odd. Must be an odd number. Greater than what? Greater than 2. So it must be an odd number that is greater than 2, because all the odd numbers starting from, remember, we are not supposed to use 1, right? So it's starting from 2 going upwards. So it must be an odd number that is greater than this 2, meaning your 3, your 5, 9, 11, 13, all the odd numbers will satisfy that, right? So that's when your n is an element of all the odd numbers, 3, 5, 7, 9, all those numbers that are odd numbers. So that's basically how you were supposed to calculate that question. So it's one of the high order questions. They do not necessarily need you to apply a lot of calculations, just a matter of understanding your maths. So they just testing your knowledge of the relationship of numbers, right? So those are one of the high order questions. These are the questions that maybe you can allow yourself to lose, right? But then all the other questions, they are within the norm, and then you should always be able to get them, right?